Many people feel nervous when they start studying for a certification because the exam itself seems like a black box, and that feeling can make even simple topics feel heavier than they really are. For ISSEP, the best way to reduce that anxiety is to replace mystery with a clear mental model of how the test behaves and what it is trying to measure. Think of the exam as a structured conversation where you have limited time, and the questions are designed to see whether you can reason about security engineering choices, not whether you can recite trivia on command. When you understand what the exam is likely to look like, you stop studying randomly and start studying on purpose, because you know what kinds of thinking the exam rewards. That is what we are doing here, building a calm, practical understanding of timing, scoring, question formats, and rules so you can focus your energy where it actually matters. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful starting point is to understand that a certification exam is not the same thing as a classroom test, even if they both use multiple choice questions. Classroom tests often reward remembering exact phrases from a lecture or a textbook, and they sometimes expect you to match the teacher's wording. A professional exam is usually more interested in whether you can apply concepts in a consistent way when the details change, because real security engineering never looks exactly like the example you practiced. That means exam questions tend to be written to test decisions, trade-offs, and the ability to spot what is most important in a situation. For a beginner, this is good news, because it means you can improve quickly by practicing a repeatable way of thinking rather than trying to collect a huge pile of facts. If you treat the exam as a test of judgment under constraints, timing, scoring, and question style start to make more sense. Timing is one of the most practical parts of the blueprint because it shapes how you should read and answer questions. You do not need to be fast in a dramatic way, but you do need to be steady, because losing pace early tends to create a rushed, error-prone ending. A good way to think about time is that each question has an invisible budget, and your job is to spend that budget wisely, not perfectly. Some questions will be quick because they are direct and you immediately recognize what is being tested, while others will be slower because they require careful reading to avoid a trap. The exam is built with that variability in mind, so the goal is not equal time per question, but consistent progress without getting stuck. When you notice yourself rereading the same sentence several times without clarity, that is usually a sign you are spending too much of your budget on one item. Scoring is another topic that causes unnecessary stress because people imagine complicated point systems, secret penalties, or special tricks that the exam uses to catch them. The simplest, most reliable mindset is to assume that the exam rewards correct answers and does not reward incorrect ones, and that your job is to maximize correctness across the whole set. Do not invent extra scoring rules in your head, because imaginary rules create imaginary fear, and fear leads to overthinking. Instead, treat each question as a fresh opportunity to demonstrate sound security engineering reasoning. If you are unsure, your strategy should be to eliminate wrong options and then make the best choice, because leaving mental energy on the table is worse than making a thoughtful guess. A steady, rational approach to uncertainty is part of what the exam is indirectly measuring, because security engineering often means making the best decision available with imperfect information. To understand item types, it helps to separate what a question looks like on the surface from what it is doing underneath. Many questions will look like standard multiple-choice items, but the real test is whether you can interpret the situation and identify what the question is actually asking. Some items might ask for the best next step, the most important factor, the strongest justification, or the most appropriate control family, and those phrases change the nature of the problem. A question that asks for the best next step is about sequence and process, while a question that asks for the most important factor is about prioritization. A question that asks for the strongest justification is about reasoning and defensibility, not just the control itself. Beginners often miss these differences, answer the wrong question, and then feel confused because the options all seem partly correct. Training yourself to notice these patterns is a major advantage. Another common pattern is that the exam will use short scenario descriptions that are not meant to be deep stories, but are meant to provide constraints. Constraints might include the type of system, the environment, the stakeholders, or a limitation like legacy hardware, regulatory pressure, or mission-critical availability. In security engineering, constraints are not annoying details. They are the entire point, because good engineering is about fitting a solution to reality. When an item includes constraints, it is inviting you to show you can adapt principles to context rather than applying a one-size-fits-all rule. Beginners sometimes try to solve the scenario like a detective, searching for hidden clues, but most exam scenarios are not mysteries. They are boundary lines that tell you which options are reasonable and which ones violate the situation. Rules are the guardrails that keep the exam fair and consistent, and they also shape how you should behave during the test. There are usually rules about what you can bring in, what you can do during breaks, and how you must handle the testing environment. Even without memorizing every policy detail, you should assume that the exam expects standard professional testing behavior, like keeping your focus on the screen, not using external materials, and following proctor instructions. The deeper reason rules matter is not just compliance, it is mental simplicity. When you already know you will follow the rules, you do not waste attention wondering what is allowed, and you reduce the chance of stress-driven mistakes. Treat the rules as part of preparation the same way you treat sleep or hydration, because they remove friction from your performance. A key idea related to rules is the difference between what you control and what you do not control. You cannot control the exact mix of topics on your exam, the exact phrasing of questions, or whether you get a question that feels unfamiliar. You can control your pace, your reading discipline, your elimination process, and your emotional reaction to uncertainty. The blueprint matters because it helps you focus on controllable behaviors that work across many possible question sets. For example, if you know you will face multiple choice items that include plausible distractors, you can practice the skill of explaining why an option is wrong, not just why one is right. That skill is controllable, trainable, and directly useful on test day. Thinking this way turns preparation into a set of behaviors you can reliably execute. Now let's talk about what makes an exam question feel tricky, because recognizing tricks is different from assuming the exam is trying to trick you. The exam does not need to be unfair to be challenging, because security engineering involves decisions where multiple options sound good at first glance. Distractors often work by being generally true statements that are not true for the situation described. Another common distractor is an answer that is too narrow, like focusing on one technical control when the question is asking for an engineering approach or governance decision. You might also see answers that solve a different problem, like improving confidentiality when the scenario's primary risk is availability. These are not gotchas. They are reminders to match your answer to the question's goal. If you read carefully, identify the goal, and keep constraints in view, the apparent trickiness becomes manageable. Because this is an audio-first learning experience, it helps to develop a mental checklist that you can run quickly in your head without writing anything down. First, identify what the question is asking you to do. Choose a control, choose a process step, choose a principle, or choose a priority. Next, restate the situation in your own words, focusing on constraints like environment, system type, and what could go wrong. Then scan the options and eliminate anything that clearly violates constraints, ignores the question's action word, or introduces something unrelated. After elimination, compare what remains by asking which option best satisfies the goal with the least assumption. That final phrase matters because the best exam answers usually require the fewest leaps, the fewest extra conditions, and the most consistent alignment with security engineering principles. This method is not a trick. It is simply structured thinking under time pressure. It is also worth understanding the difference between recognition and recall, because many learners think studying means collecting facts until they can recall them on demand. Exams like ISSEP often reward recognition of patterns and principles more than perfect recall of isolated details. Recognition means you see a situation and you recognize which principle applies, such as least privilege, defense in depth, fail-safe defaults, or separation of duties, and you can explain the engineering reason behind it. Recall is still useful, but it is secondary because security engineering is not a vocabulary contest. When you study, Aim to connect terms to decisions and decisions to outcomes, like how an architectural boundary affects attack paths or how assurance evidence supports confidence. That kind of connected knowledge is easier to retrieve under pressure because it forms a story in your mind rather than a flashcard list. The blueprint helps because it nudges you toward the kind of connected understanding that question writers expect you to demonstrate. Another practical topic is how the exam handles uncertainty and how you should handle it as a beginner. You will encounter questions where two options seem close, and at that moment the test is asking whether you can choose the better engineering decision, not whether you can eliminate everything easily. When options feel close, look for differences in scope, sequence, and defensibility. One option might be a good idea later, but not the best next step now. Or it might be technically strong, but unrealistic given the constraints. Another option might address the root cause while the other addresses symptoms, and security engineering usually prefers root cause approaches when feasible. If you can explain to yourself why one choice better matches the question's goal and constraints, you are doing the right kind of thinking, even if it feels uncomfortable. Learning to remain calm in that discomfort is a measurable advantage. Exam discipline also includes how you review and how you avoid changing correct answers into incorrect ones. Many people feel that reviewing means doubting themselves, but a good review is more like quality assurance. You verify alignment between the question's goal and your chosen option. If you flagged a question because you felt rushed, review can be valuable because you might notice an action word or constraint you missed. If you flagged a question simply because it was hard, review should be careful because second-guessing without new insight often leads to worse outcomes. The best time to change an answer is when you discover a concrete reason your original choice fails the question, such as violating a constraint or answering a different question. Review should feel like confirming logic, not like rewriting history. Thinking of review as a disciplined engineering check keeps it rational and prevents emotional drift. Finally, it helps to place the blueprint in the larger purpose of ISSEP, which is about security engineering as a discipline that connects technical design, system lifecycle thinking, and assurance. Even when questions appear to focus on a single concept, the exam often expects you to think across boundaries, like how a requirement influences architecture, how architecture influences risk, and how risk influences validation and monitoring. That cross-boundary thinking is why timing, item types, and rules matter so much, because they create an environment where your reasoning process must be efficient and consistent. You are not being asked to be a perfect engineer. You are being asked to show that your thinking follows reliable principles. When you can interpret a question, identify its goal, apply the right principle, and choose a defensible option within the time constraints, you are demonstrating the competency the exam is built to measure. That is the real meaning of decoding the blueprint. You are learning how the exam communicates what it values, and you are learning how to respond with steady, principled judgment.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.